Hello, and welcome to Group 2's research report presentation on Google's driverless car. What is a driverless car? The Webster Dictionary defines autonomous as having the right or power of self-government, or undertaken or carried on without outside control. A self-driving car or an autonomous vehicle has the ability to make decisions and carry on its mission without the need of any external control. This means once a car knows your destination, it can drive there without any human intervention and will follow laws and react to its environment in the appropriate manner. Destination can be scheduled or determined automatically based on habits in the future. The Society of Automotive Engineers, SAE, defines standard levels of autonomy by providing common terminology for automated driving. It defines 6 levels of driving automation, from no automation to full automation, as shown in this table. Based on the SAE definitions, most modern vehicles have standard equipment for level 1 at a minimum, like ABS braking, traction control, and stability control. The majority of cars are now offering level 2 functionality, with a combination of steering assist and automatic cruise control. Some cars, like Tesla's, are already offering level 3 features, such as autopilot, and will be offering level 4 fully autonomous features in the near future. We are still years away from level 5. Radar and LiDAR give us information to help locate the obstacles in the environment. Visible light cameras and stereo vision give us texture information. They help us to know not only where the objects are, but what they are as well. GPS and IMU sensors give us information about the vehicle itself. The vehicle's controller area network, or CAN bus, tells us the state of the vehicle, what each system is doing, etc. Audio information, such as the sounds of the road, provide context, like whether the road is wet or covered with snow, or if other drivers are honking their horns. Internal facing sensors focus on the driver, sensing what the driver is looking at, and help determine if they are tired or other information about their emotional state. Google's Waymo self-driving cars contain 3 LiDARs to create a 360-degree view and to create a 3D model of both close and far objects. 5 radars for 360-degree view, which are highly effective in rain, fog, or snow, and 8 vision modules, each using multiple sensors, plus an additional forward-facing, super high-resolution multi-sensor module. Intel computing hardware is used to process the sensor data. For an autonomous vehicle to work, it needs to do 2 key things: understand and perceive the world, and then make decisions to complete its mission to arrive at its destination. The vehicle uses statistical algorithms to interpret sensor data and static information, such as road markings and traffic signs, to build its perception of the world. The decision-making is then performed by machine learning algorithms. A key machine learning task for automated driving is automated reasoning. It needs to use the stored information to answer questions and to draw new conclusions. One of the most common methods utilizes artificial neural networks, which are inspired by biological neural networks. The biological neuron is the computational building block for the brain, while the artificial neuron for machine learning is the computational building block for artificial neural networks. It takes a number of inputs, takes their weights, sums them together, applies a bias value on each of them, and finally uses an activation function to aggregate them to one value. A large amount of training data is required to allow these supervised machine learning algorithms to make accurate predictions. In the future, we can expect more general-purpose intelligence algorithms, which will require less training and will produce more natural reasoning. Driverless cars often implement an ad hoc peer-to-peer network in order to communicate with each other. This network can be used for safety features such as pre-collision warning, path triangulation, and even to determine with traffic conditions, which are used to provide the quickest possible route to a destination. In 2009, Google's self-driving car project began with the formation of Waymo. Google is not planning on selling the car themselves, but rather they want to sell the self-driving technology that can be applied to many cars. Waymo stands for A New Way Forward in Mobility. Google has racked up over 3 million miles in test drives. In August 2016 alone, their cars traveled a total of 170,000 miles, of which 126,000 miles were driven autonomously. Google has tested their self-driving cars across multiple locations in the US, including cities like Mountain View, California, Austin, Texas, Kirkland, Washington, and Metro Phoenix, Arizona. Legal frameworks are put in place to hold those responsible and accountable, whether it be due to fault or negligence. Autonomous vehicles are in a legal class called products liability, in that an autonomous vehicle is a product. The argument is that current legal frameworks already encompass autonomous vehicles because autonomous vehicles function similarly to technologies such as cruise control. Cybersecurity is becoming more prevalent in today's society, as hacks today are a huge spotlight, especially with recent attention to Equifax. Certain legal sources state that the resulting liability would be with the manufacturer. Other legal sources, however, claim that the driver is ultimately responsible for the performance of the vehicle. This, however, brings into question the purpose of an autonomous vehicle that still requires a human driver to be constantly monitoring the situation. Because of this, the road forward for autonomous vehicles from a legal perspective is still unclear. In the future, we can expect wider spread adoption of driverless vehicles. The push for more autonomous cars will be driven by integration of more sensors with greater accuracy, improved networking between vehicles, and new laws and regulations which will address the current questions of liability. These factors and more will pave the way for the driverless cars of the future. Thanks for listening.